Hi everyone, now we are going to see the working principle of attenuators. Attenuators are the passive microwave devices which are used to reduce the microwave power. Thereby, it protects the sensitive microwave devices. An attenuator is an electronic device that reduces the power level of a signal without distorting the signal. An attenuator is effectively performs the opposite function of the amplifier, where amplifier amplifies the signal so it has effective gain, whereas attenuator has gain less than 1. Attenuators are usually passive devices that are made from simple voltage divider network used to control amount of microwave power flowing from one port to another port, and also it reflects and absorbs the energy in some form of dissipative elements. Attenuation is a function of frequency. Basically, there are two types of attenuator. One is fixed type attenuator, another one is variable type attenuator. Fixed type attenuator provides the constant amount of attenuation, whereas variable type attenuator provides the different levels of attenuation depending on the requirement. Basically, a attenuator consists of short section of waveguide with a tapered section of absorbing material. The tapering is done for providing a gradual transition from the waveguide medium to the absorbing medium in order to reduce the reflection. Mainly, attenuators are used to match the impedance by lowering the standing wave ratio. This figure shows the cross section of fixed type attenuator, which has a section of rectangular waveguide. Inside a dielectric slab is placed. One face of the dielectric slab is tapered in order to avoid the reflections. The amount of attenuation actually determined by the length and thickness of the dielectric slab. Some of the important performance characteristics of the fixed type attenuators are input and output impedances, flatness with frequency, that means level amount of attenuation does not change with the frequency, average and peak power handling capability, final one is temperature dependence, that means the irrespective of the variation in the temperature, the attenuator must provide the constant level of attenuation. The variable attenuators can provide continuous or stepwise variable amount of attenuation. Either it can be made by using a rectangular waveguide or by using a circular waveguide. If it is made by rectangular waveguide means it will be having of two types, either flap type or vane type. If it is made by circular waveguide means it will be having a rotary type. Variable attenuation can be classified into a flap type attenuator, a movable vane attenuator, variable type waveguide attenuator, finally rotary type vane attenuators. A flap type attenuator consists of a resistive element or a disc inserted into a longitudinal slot cut along the broader dimension of the waveguide. The amount of insertion determines the level of attenuation. If it is inserted more means the amount of attenuation will be more. If it is less inserted means the level of attenuation is very less. A flap type attenuator consists of rectangular waveguide and a slot along the broader dimension of the waveguide through which a dielectric slab is inserted. The amount of insertion determines the level of attenuation. In movable vane attenuator, the vane is positioned at the center of the waveguide and it can be moved laterally from center to the edge. Whenever the vane is placed at the center, it will provide the maximum attenuation. When the vane is moved to the edge of the waveguide, at that time it provides the less amount of attenuation. In a variable type waveguide attenuator, a resistive cord is moved from one side of the waveguide to the center by using the screw. In the center point of the waveguide, E field is considered to be maximum. This resistive film is shaped to give linear level of attenuation. Whenever the resistive cord is at the near to the wall, it provides the minimum attenuation. When the resistive cord is at the center of the waveguide, it provides the maximum attenuation. A rotary vane attenuator provides the more precise level of attenuation irrespective of the change in the frequency, and also it consists of three sections. There are two rectangular to circular waveguide transition and one circular waveguide at the center. The rotary vane attenuator totally consists of three resistive cords, out of which two resistive cords are placed in the rectangular to circular waveguide transition where it provides the fixed level of attenuation. and one resistive cord is placed in the center circular waveguide. The position of the resistive cord can be changed by rotating the circular waveguide. Whenever the resistive cord is perpendicular to the incoming microwave signal, means it provides the less attenuation. Whenever the orientation of the resistive cord is parallel to the field component of microwave signal, means the attenuation will be maximum. Thereby different levels of attenuations are achieved.